To run iRank, we should go through 4 steps that are already numbered on the user interface. Here we use a toy example to display how to run iRank. iRank deals with 2 data types, network and list. iRank accepts tab delimited text files as input files. A single text file contains either a single network or a list. In our toy example, we are going to integrate several networks into a composite one, so we need to upload several text files. By clicking the Upload File or Directory button, the user can upload either one single text file or one single folder that contains all text files you want to upload. Once files are successfully found on the computer, iRank will display all file names in this file box. In Step 2, you can browse or edit the file that is selected in Step 1 file box. To browse file, click the button Show, and file will be displayed as a data table. In this data table, all entries are editable except for column names. To edit file, put mouse into the entry you want to edit, and edit it, and then click the Save button to save what you edited. In Step 3, the user can specify the filtering criteria for the selected file. iRank filtering is attribute-based. It means a network or list is filtered by the filter you set for each of its attributes. For example, this selected network has 2 attributes, correlation and purpose. We will filter this network by setting a value range for correlation and a certain label for purpose. After clicking the Edit button, a 3-column table will be displayed. The first column displays all column names in the selected file. The second column has blank entries that will show a drop-down list. Once they are hit from this drop-down list, the user can select an appropriate column property and operator. In current version, this selectable list has 2 types of column properties. The first type is the identifiers such as the element in a list and the node in a network. They are not attributes, so they do not associate with operators. The second type is attributes, which are further divided into value attribute and label attribute. Value attribute is treated as mathematical value, while label attribute is string tag. Value attribute is associated with operators such as greater than, less than, equals, etc. And label attribute is associated with operators such as contains and equals to. These operators will be used in conjunction with filters in the third column. In the third column, the user types in the filters that correspond to the column property. When multiple attribute columns have filters, these filters will be applied simultaneously. That means the AND operator is applied to different column filters. For the second network, we would like to treat it as a directed network. That means edge in this network has a direction. So we choose from node and to node. For the identifiers, this network has 1 attribute, relation. Now we have multiple labels in mind for this attribute, and we think each of them is okay to pass. In this case, we need to set multiple filters for this relation attribute. Type in these filters and separate them by semicolon. What we just displayed is one situation, that multiple filters are needed for a single attribute column. The other situation is when both bottom value and cap value are needed to get a mathematical value range. In that case, choose 2 operators in the second column and type in 2 values in the third column. Separate the 2 values by the sign of AND. After we are done with each file, for filtering criteria, we can go to Customize Integration Pool by selecting multiple files in the checkbox list. In this step, we also need to indicate data type. This toy example is network, so we choose network. In the last step, we still have an option on whether to apply the filters we specified. Here we would like to apply the filters, so we choose yes. Now we can click the Run button to run the program. After running is done, a message dialog will appear. For list data, only text output is selectable. This toy example is network data, so we choose visualization since visualization window also provides text output. There are two major components in the visualization window. One is the integrated network, and the other is two statistical plots. In the first plot, x-axis is node degree and y-axis is the number of nodes that are above this node degree. Node degree indicates the number of interacting partners one node has, so the higher node degree a node has, the more connected this node is. In the second plot, x-axis is edge reoccurrence and y-axis is the number of edges that are above this edge reoccurrence. Edge reoccurrence indicates the number of times an edge appears across different network, so higher edge reoccurrence might suggest more reliability. All data points in the two plots are clickable to update the integrated network. For example, we would like to keep only edges that have edge reoccurrence above 2. In the integrated network, node is represented by small circle and node size indicates its node degree. Edge is represented by line and line stroke suggests its edge reoccurrence. Undirected edge is represented by blue line, and directed edge is denoted by a pink line with a pink arrow. When the directed and the undirected are merged together, the hybrid edge is shown as a blue line with a pink arrow. Click left mouse to show or dissipate the node label, and click right mouse to show or dissipate the edge sources. You can save current visualization as image file. You can also export results as text file which can be re-uploaded to iRank for visualization. If you are interested in only what nodes or what edges are in this integrated network, you can export only nodes or edges. Now we are going to try a real example. For data sources, please read descriptions below this video.